All right, so on this slide, it's a list of the different laws we're going to cover in this unit. And there are a few things you need to know about these laws. Well, one, you know how to use them properly, for one. Be able to identify and recognize what equation you're going to use based on what you're given. Being able to rearrange the equation properly. Your temperatures need to be in Kelvin, and your units need to be consistent throughout the whole conversion, or solving the problem at least. So today's lecture is going to be Charles and Boyle's law. That's what we're going to cover today. And the other four we'll cover over the next couple of weeks. Charles's law. So Jacques Charles, there's a demo that I posted on Google Classroom. What's going to be on there. And this one is the soda can demo. So watch that, and hopefully that'll explain how this law works. So the volume of a gas varies directly with its Kelvin temperature as long as the pressure and amount of gas is constant. So Charles's law is focusing on volume and temperature only. If two things vary directly, that means if one goes up, the other goes up as well. So the Charles's law is volume 1 over temperature 1 equals volume 2 over temperature 2. Make sure that your temperatures are in Kelvin and that your volume units are consistent. So if it's liters or milliliters, as long as it's the same, it's okay. Calculating a new volume caused by a change in temperature. A 750 ml volume of air is heated from 25 to 100 degrees Celsius at constant pressure. What is the volume of air at the higher temperature? So first thing you need to do is identify what you're given in the problem, and that will hopefully tell you what law you're going to use, because when you have different ones, it's going to be a little confusing. So we have a volume. This is my first one. And a temperature here. It's heated to a different temperature. Pressure is constant, so we ignore that. What is the volume of air at the higher temperature? So what is my new volume after I heat it up? So my law, V1 over T1 equals V2 over T2. I am trying to solve for this one right here. So to do so, I need to cross multiply. So V1 T2 equals T1 V2. I am trying to solve for V2, so I divide both sides by T1. So volume, it is going to be, so V1, so 750 mLs. So then my T2 is 100 degrees Celsius, but it has to be in Kelvin. So that's going to be 373 Kelvin. So then I'm going to divide this by 298 Kelvin. So notice how I am putting the units in this. And the reason why is because it's going to help you cancel out units if you're confused by which one you need. So volume 2. K's cancel out, so I'm left with milliliters. 750 times 373, then divided by 298. I end up with 938.7583 ... milliliters is my V2. So looking at this, I want my sig figs. So it's going to be, let's just base it on the volume. So it's going to be 940 mLs. Okay. Calculating a new temperature to cause a desired change in volume. So a gas thermometer contains exactly 226 mLs. So this is volume. At a temperature of 21 degrees Celsius. So this is the temperature. At what Celsius temperature will the volume be V? Well, 240 mLs, I'm sorry. So V1, T1, T2, V2. So remember your Charles's law, V1 over T1 equals V2 over T2. I am trying to solve for T2. So T1 times V2 divided by V1 is that's my rearranged equation. So I need to convert degrees Celsius into Kelvin. So 21 plus 273, that is 294 Kelvin. I'm going to plug in my numbers. 294 K, V2 240 mLs, 226 mLs. Those cancel out. The units, 294 times 240 equals 70,560 divided by 226. Looks like my temperature is 312.212, blah, 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 blah. So let's just keep so it's at what Celsius temperature, so I got to convert it back. So 312 degrees Kelvin, if I want to get to Celsius, remember degrees Celsius is plus 273, so I need to subtract by 273 to get my Celsius. So 312 minus 273, so 39 degrees Celsius. Okay, real life application of Charles's law. So now a lot of you guys are going to be driving, or you already are driving already. You'll notice that if the temperature drops, and the weather gets colder, etc., the volume, something happens with your car. You may notice that it's riding a little bit differently in terms of your tires acting kind of funny. Maybe there's a light in your car that says, hey, check your tires. There's something wrong with them. So this is the effects of Charles's law. As the temperature drops outside, so does the volume of gases. So the volume of the gas in your tires will drop because the temperature is dropping. Once the temperature starts going back up, the volume will go back up as well. So it's important to get your tires checked to make sure that there's not anything wrong with them, etc. And they will tell you that, oh, it's just the temperature change, you'll be fine, etc. So make sure you watch the video that I attached on Google Classroom for this. That will help explain this more. So real life application of Charles's law, it is the volume of your tires changing when it gets cold, and the demonstration in terms of the soda cans. I heated up the cans. I put a little bit of water there. I heated up the gas inside. The volume increases because the temperature is increasing. So I quickly put it into a bucket of cold water, and the volume decreased rather rapidly. So temperature decreases, so does volume, directly related in terms of temperature and volume.